Hey everyone, welcome back. So today we have another lead code problem of the day, that is find the minimum and maximum number of nodes between the critical points. So this is a medium level linked list problem, and let's just read the problem statement and try to understand what they are asking us. A critical point in a linked list is defined as either a local maximum or a local minimum. So they have given us a definition of local maximum, that is, uh, if the current node value is strictly greater than the previous and the next node value, then it is called local maxima. And the local minima is the opposite if it is strictly smaller than the previous node and the next node. Okay. Now, uh, what they want us is they have given us a linked list with the head, and we have to return an array of length 2 containing minimum distance and maximum distance. And the minimum distance definition is the minimum distance between any two distinct critical points, and maximum distance is the difference between any two distinct critical points. Okay, so let's just try to understand it with the problem with the example that will be this example. I find it as a perfect one. Let's just see. What they are asking is, first of all, what is a critical point in anything? Okay, critical point will be something which is smaller than uh, the previous and the next value, or it can be the largest one from the previous and the next value. Let's just take an example. In this linked list, what are the critical points that you can observe? So the first critical point that I can see is this, that is 1, because 1 is smaller than 3 and 2, and the next critical point will be 5, which is again greater than 2 and 1, and the next critical point will be 1, that is again 5, less than 5 and 2. So these are the three critical points that we have, and now we have to return the minimum distance between these critical points and the maximum distance from this critical point. How are we going to find it? It's just about indexing of the linked list. The linked list starts with 1, 2, 3, 4, 5, 6, and 7. And now the critical points indexes are 3, 5, and 6. So the minimum difference in these critical points will be 5 minus 6, that is 1, and the maximum will be 3 and 6, that is 3. So the answer will be 1 and 3 for this particular problem. Now, how do we get this in coding solution? How we can approach this particular problem? So as we can see that if you observe carefully, then this problem becomes pretty much straightforward linked list, typical linked list problem. And the solution will be, first thing is to store the indexes of all the critical points. Okay, and to do that, we will be needing again 3 pointers in linked list. Uh, First pointer will be our head. Okay, that is our current. Then the next pointer will be current, and the third pointer will be our post. Okay, so it will be easier for us to check the value. Similarly, we will be traversing it in a sliding window fashion. That means first we will check these values, then we will check these values, then we will check this set of values, and then this, and similarly this. And from this, we will be identifying all the critical points, and if we find any, then we will be pushing the index of that in our array. And to push that index, we will have an index variable. We will be having an index variable. So like we traverse, I will be showing in a code how we will be traversing it using 3 pointers. And once we have the indexes, that is 3, 5, and 6. Now, the basic understanding about local distances, like, the distances between these is the maximum distance that you can get will be always from the first till the last point. Okay, that is always sorted. And then all we have to do is we have to check the minimum distance, that will be the adjacent distance. Okay, 3 minus 5, 5 minus 6, and we have to take the minimum value. So it is pretty much easier once you understand how it works. You can try it with the example using 3 pointers. Store the indexes value in an array and try to find the maximum difference and the minimum difference. So let's just code it in C++. The first thing I will be doing is I will be assigning a vector of array, and in this we will be storing our critical point indexes. I will be naming it index. Then we will be needing two pointers, that is list node star current cursor, let's just say cursor. It will be pointing to our heads next, and list node star post. It will be pointing to cursors next. Okay. We also have to check if our linked list have this pointer or not. Okay. So we will add a condition here, that is uh, if cursor next is equal to null pointer, then all we have to do is return -1 -1, because there will be no solution for that kind of linked list. Now we have to get the index. I will be naming it as IDX, and I will set it to 2 because we will be starting from the second value itself. Now we will run a while loop. This while loop will run till the point our post is not equal to null pointer, and now we have to check the condition. Okay. Now the first condition will be if our cursor value is greater than previous value, that is head value, and our cursor value is also greater than post value. Okay. If this condition is true, either or, I will just copy this. We have another condition that will be for minimum values. All I have to do is change it to minimum if the cursor value is less than head value, or if the cursor value is less than the post value. If we encounter this condition, all we have to do is we have to push the value, our index. Okay. And now we have to increment our pointers. Okay, we have to slide the window to next value. And how we are going to do it? We will be pointing our head to cursor to post, and post to post dot next. And we will also increment our IDX as we move forward. Now, once we have this, there will be again a condition that we have to check. If there are less than 2 critical points, that means we don't have any answer. So all we have to do is return again the -1 -1. All we have to do is that, and size is less than 2, then return -1 -1. And if that is not the case, then we can find our maxima from just absolute difference between index of 0 minus index of index dot size -1, that is the last element. And for int minima, I will set it to maximum, and we will run a for loop till second last value. And all we have to do is we have to check the minimum value of absolute difference between index of I minus index of I plus 1. From this we will get the minimum value, and we have to return the answer. Okay, hopefully it runs. So as you can see, we have to run this code now, and I have solved few of the bugs. That was this typing error, and it is accepted. We will submit it. Okay. So it's a O of n solution, and because we are just traversing the linked list forward, and also we are traversing the indexes array just for one. So the solution is O of n. Thank you.